Alrighty, class, here we are. We're gonna look at the second question today on the FRQ methods and control structures 1. So again, I've put together 5 problems that are meant to help you prepare for the AP exam. These are all free response questions, which is, I think, in my opinion, I guess one of the best ways to prepare. There are multiple choice. There's a multiple choice portion as well, and we'll make sure to prepare for that. But for now, we're working on these FRQs. We did AP calendar. There's videos for that. Now we're looking at this second question called Combinatorics. And it's a very simple class. It's actually a very simple implementation, but it's easy to confuse what they're asking you. So let me make sure I go over this again. I did ask that you post any questions you had prior to me posting the video, and so quite a few of you posted your questions, or you commented on a few things, and again, I appreciate that. It lets me, when I make this video, it guides me as to what things you were confused about, and so it lets me work in that with your questions in mind. I'm going to copy all this because I want to test this. I want to make the two methods. This is old. I can just close this. AP calendar, that's what we were working on before. We're going to do new Java. Unlike the AP calendar class, I haven't coded this one, but it's actually a very simple class, and so I'm going to be coding here in real time. I'm not going to be copying and pasting code from before because I haven't done this problem yet. Okay, let's first talk a little bit about the precondition here. There was questions on the precondition. The precondition is that n is always going to be a number between 1 and 12, inclusive. Now, inclusive, again, there was a question on inclusivity. There's also a question on why it has to be 1 and 12. Inclusive means that it can be a number between 1 and 12, including 1 and 12. So n can be 1, 2, 3, 4, so on and so forth, up until 12. If it said a number between 1 and 12 non-inclusive, so if you had a non-inclusive, it could be any number between 1 and 12, not including 1 and 12. So like 2, 3, so on and so forth, up until 11. But this is inclusive. Now, one of the students mentioned, well, why 1 and 12? There was a question about that, and that has to do with the fact that you are basically storing data. You're storing information, numbers in this case, and there are limitations when you store data. And so in this case, the factorial, which is basically you multiplying n times itself. Well, I guess not times itself. It's basically you multiplying n times all the numbers less than n down to 1. When you multiply numbers, for example, if you get 12 factorial, and I'll write it here in the comments, 12 factorial, which in mathematics we denote as 12 with an exclamation mark, is equal to 12 times 11. Let me get this right here. Times 11 times 10 times 9 times 8. And you'll find that this is a huge number. Like, it's a very big number. You can look it up. But what's true is that this number is still within bounds. It's still within the limits of what you can store in a data type of type integer. So there are restrictions when you're storing variables on what the biggest number you can store on that variable. So you'll find that if you go to 13 factorial, which would be basically the same as 12, but instead of starting at 12, we'd start at 13. 13 times all the numbers less than 13 up to 1. Then this number, 13 factorial, it exceeds the storage capacity that you for an integer. So the number is too big. Now I'll do a quick search so that you don't have to just believe me for what I'm saying here. I'll put here int data type, and it gives you some information here. So it says a data type of an int it requires 4 bytes. So that's the amount of storage capacity that you have. 1 byte is 8 bits. And so you can store 4 times 8, 32 bits. And the biggest number, positive biggest number that you can store is about 2.1 billion. This is 3, and 3, that's 9, 10 total digits. So roughly a little more than 2.1 billion is the biggest number that you can store. Now, if I look up 12 factorial, you'll see that this number is still less than that. It's, we have here 3, that's 479 million. So it's still less than the 2.1 billion. But now if I look up 13 factorial, I gotta press enter here. Now the number is bigger than the 2.1 billion. That's 800, and then the billion place, and then the billion. So it is 6.2 billion. And so this number, 13 factorial, would exceed the storage capacity for a data type int. It's bigger than 2.1 billion. Now, there is another data type called long, which gives you more storage capacity. The biggest number you can represent with the long, well, first of all, it's 64 bits worth of information, whereas an integer is 32 bits because it's 4 bytes and each byte is 8 bits. So 4 times 8 is 32. So you can store 64 bits worth of information, so significantly more. And the biggest number you could represent with the data type of long is this, 2 to the power of 63 minus 1, which is huge. It's a big number. And so if you want to store numbers that are bigger than 12 factorial, you'd have to use a data type of long. And so because we are returning an integer value, and this is straight from the AP sample question, so it's not me making this up, it's straight from there. Because we are returning an integer, it is true that our number n can only be a number between 1 and 12. Now, what would happen if n was 13 or 15 or any number bigger than 12? Well, your code would break. And we can try that out. We can test it out so you can see that happening. In any case, 12 factorial is, or any number, by the way, that's what the n represents, any number, n. N stands for number. Any number, if you get its factorial, 12, in this case I'm just going to be working with 12. You're multiplying that number, 12, times all the numbers that are less than 12, then n, down to 1. This is a case where we have repeated multiplication. Now, in class I mentioned how one way to do this would be something like this. Int fact equals, well, we say something like n. I want to multiply n, that's 12, times n minus 1, which would be 12 minus 1 is 11. So 12 times 11 times, and then n minus 2. That would be 12 minus 2 is 10. So 12 times 11 times 10 times n minus 3. But there's a problem with this mechanism. Now, again, this could work potentially, especially if we have like n equals 12. But right here, I'm hard coding these values to an extent. We're hard coding. We're making an assumption. We're assuming that we know how many times we have to subtract, how far we have to go down. For example, if we had like n equals 3. If n was 3, this would be 3 times 2 times 1 times 3 minus 3 is 0. And so this implementation that I have right now would not work for n equals 3 because it would give me 0. And 3 factorial is not 0. I'll write it right here really quick. 3 factorial is actually a very quick calculation. 3 times 2 times 1. God, there we go. And we stop at 1. We don't want to multiply times 0 because then we would get 0 and it would defeat the purpose. So times 1 is 6. 6. 3 factorial is 6. So if I send argument of 3 here, and it gets stored in this parameter n, and if I have this implementation, it would be 3 minus 1 is 2, 3 minus 2 is 1, 3 minus 3 is 0. So 3 times 2 times 1 times 0, and you return 0, and that's not what you want. So again, this is technically what we're doing, but we don't want to implement it this way. What we do have here is repeated addition. Multiplication. We have repeated multiplication. And so I can actually start factorial at 1, which is what you would get if n was 1. If n is 1, you'd get 1. And so I could say something like, while, let me think here, n is greater than, we could probably do equal, or equal to 1. I want factorial to be what it used to be, times whatever n is. And then in a while loop, we have to always, within the while loop, we have to update the variable that is keeping count of the loops, or I guess the one that we're using in our Boolean expression, our conditional statement. So n is greater than or equal to 1. Because suppose n is 12, 12 is bigger than or equal to 1. So it would be fact equals 1 times 12. And then I want n to decrease. I want the next value of n to be 11. So I would subtract 1 from n, which we can do this. By the way, there's a short way of writing this expression. Factorial equals itself times n. We can say factorial times equals n. So shorthand notation here for writing factorial equals factorial times n. The last time we come in here is going to be when n equals 1. And so factorial is going to be whatever it is times 1, which won't change its value. So we could actually just say while n is greater than 1 instead of greater than or equal to. And then we can return a factorial. I believe there might be in the actual problem description something about recursive methods. I know there was a question by a student asking me about recursive. You're encouraged to implement this method recursively. This year, because of the changes to the administration of the APCSA, you will not be tested on recursive methods. So I'm gonna skip this for now. I guess I'm trying to avoid making this video longer than it needs to be. But recursive methods is just they're not necessarily like special methods. They're just a method, but it's a method that calls itself within its implementation. So I'm gonna skip this. If you have more questions on recursive methods, please reach out to me. You won't be tested on it. So technically, you wouldn't get a problem that encourages you to use a recursive method. By the way, right here it says you are encouraged, not required. So even if you coded the factorial method without using a recursive method, you'd be fine. And so I'm going to skip the recursive method. If you have more questions, please let me know. Okay. Let's see here. This combinations, which we're going to implement in part B, is not returning anything, so it's void of a return. I'm going to leave that as is. I'm going to compile, which means that it's going to ask me to save. Combinatorics.java, that's good. And then we're going to go in here to AP Computer Science A for response questions and combinatorics. That's good. Now I want to make a tester class. Because actually, as a matter of fact, we are having the same. We have the same scenario that we did with AP calendar, which is this method, the factorial method, is declared as a static method, which is convenient for us because we don't have to set up a separate combinatorics tester class, if you will, with the main method within. We can actually code our main method in this class. Now, you would not have to do this in the actual response, the free response question, because they're not asking you to test your methods, but because we want to know if we did this right, we want to test our methods. So in here, I'm gonna actually code the static method. Again, I can do it in here because factorial is a static method, and so is num combinations is a static method. And so I can just code the main method within. The reason, again, is because you can only reference a static method like factorial from within another static method like main. And so in here, I'm going to say, I want to test factorial. I want to print what factorial returns to me when I send it the number 3, because I know 3 is an easy one. So let me start off with that. I'm going to run this. Public static, I forgot void here. Compile and then run. 6. Okay, so that looks good. 3. The 3 factorial is 6. You can do another quick one by just putting 4 here. 4 times 3, so that would be 4 factorial. 4 times 6 is 24. And so I'm expecting 24 if I send 4 factorial. That's good, it's working. Now let me go in here and, I don't know, look one up, like maybe 7 factorial. 5040, so let me try 7 then. 7, oh, there we go, 7, compile and run. 5040, so it's looking good. Now let's try 12. 12 is technically as big as a number as we can. Well, I didn't try 1. Let me try 1 first. It should return 1. Good. Let me erase this. Wait, that's not okay. 12. 12 is the biggest number I can send, and that's here in the precondition. They're saying n can be a number between 1 and 12, including 1 and 12. So any number between 1 through 12, that's the precondition, which means that you shouldn't worry about numbers bigger than 12 in your coding here. Now, if I compile and run, notice I don't get any compilation errors. There's no errors when I compile because they don't know whether I am sending a legitimate number until I run the code. And so if I run this, it gives me this big number. It's 479 million and 1,600. Now, I'm expecting, if I send 13, I'm expecting to get an error. We'll see what kind of error we get. There's no compilation error. There's two different types of errors. Compilation error, when maybe you forget a semicolon or you forget to put a return statement. So you compile your code and the computer catches those errors. And there's runtime errors, which is what I'm expecting here. When I send the number 13, I expect to get a runtime error because I expect the 13 factorial to be a number that's too big to be able to store in a data type int. So I'm going to compile again, and there's no errors, and I'm going to run. And it actually works. I guess I was expecting a runtime error, but it's not the right answer. So 3, 3, and 3. This answer right here is 1.9 billion. I wonder if that's the biggest value that you can store in an integer. Let me just look here really quick, because I know I had it here. So data type int. Well, the biggest number you can store is 2.1 billion. So I guess if I'm honest, I'm not sure exactly. I really am not sure what's going on. Give me a minute here. Excuse me about that. That was the baby here. That's what happens when you have a newborn in the house. But okay, now I'm back here. So, in all honesty, I'm gonna have to look into this, and then I can post some answers here. What I am noticing is that the number is not the correct number. So 15 factorial is definitely not this value. However, this value happens to be, it's 2 billion roughly, happens to be less than the maximum value that you can store in an integer. In an integer, you can store 2.1 billion. So I'm just curious here. Let me up this to like 30 because I want to see if I still get a number less than 2.1 billion. And we have 3, 6, 9, 1.4. So it actually went down. This was like 15 factorial. That number is bigger than 30 factorial, which makes no sense. So the code didn't necessarily break as I was expecting it, but it's definitely not working. So the last value that it works for is 12 factorial, which is the whole purpose for these preconditions. The preconditions are meant to allow you to write your code without worrying about numbers that might break your code. So like 13 would not work here. Now, let me do one more thing. Let me actually put here, just change this to a long, which means I would have to change the variable here to a long. And then let me try 13 and see if I get the right answer. I know I didn't get it when I had an integer. 6.22 billion. Now if I go to 13 factorial 6.22, so it works. Okay, that's good, because I've told the computer to allocate more bits. So more bits means that you can store more ones and zeros, and when you store more ones and zeros, you give yourself more storage capacity, and so you can store bigger numbers. Now, in the first response question, it says this has to be an integer, and so the biggest number that we can code and still get a right answer is going to be 12. Now that works good. Let me pause here for a minute because I want to look up a document, but for privacy purposes, I don't want to put the student's name. Okay, here. What I have here is my response to a student's question, which has to do with part B of this code, of this problem. So if we look at part B, oh, it was right there. This always happens to me. Part B says that they want you to code this method called number of combinations, and the student was really just confused on how this worked, and so I try to provide an explanation. They do so here by providing some scenarios, some values for n and r, which are the two parameters to num combinations right here, int n and r. So if you send 2 and 4 or 5 and 3, and so what I try to do here is provide some sort of clarification in my answer. I looked at the second test case. There are 10 ways of choosing 3 items from 5 choices. And so n is 5 here, and r is 3. Now, I try to provide some explanation here. The 5, n, is supposed to be the number of possible choices you have. So I said, okay, suppose you have 5 marbles, each with each being a different color: red, blue, green, and yellow, and orange. And then R is supposed to be, okay, well, what if you want to select R number of marbles from the 5 that you have? Well, suppose you want to select 3 marbles randomly from your 5 possible choices. So you have 5 marbles. say you have them in a hat, and then you reach into the hat 3 times and pull out a marble each time. And the question is, what combinations could you get? Now, each marble is a different color. And so, say I reach in and I get 3 marbles and I get red, blue, and green. These 3 marbles. Okay, well, that's one combination. Okay, well, then what if you reach in and you get a different combination? Well, maybe you get the red marble, you get the blue marble, and then not the green, but instead of the yellow marble. So that's another possible combination that you might have. And you go through the process and you list all the possible combinations, which I did. I was missing one for a while. I only had 9. I didn't know which one it was, but I finally got all 10. And there's 10 possible scenarios that you could get, 10 possible combinations. If you reach into a hat that has 5 marbles of different colors and you pick 3. And that's what this method does. It tells you the number of combinations you can get. So if you have 5 marbles of different colors, you reach in and you pick 3, you could potentially get any of these 10 combinations. And that's the formula, okay? That was the question. Well, I'm not sure what's going on. Well, that's what's going on. And the formula you're given is this right here. This is the way you determine how many combinations you can make. You take the number of possible marbles, 5, and you get its factorial. And that's convenient that we already have a method that does that. You get the number of marbles you would take out from the bag, 3. And that is up to you. It could be 3, it could be 2 marbles, it could be 4 marbles, it could be all 5 marbles. By the way, if you take all 5 marbles out of the bag, so if n is 5 and r is 5, then I would expect your answer to just be 1. Because if you get all 5 marbles, then there's only one way, there's only one combination, it would be all 5. And you have this equation, this formula basically, that tells you the number of combinations. Don't worry too much on how this works. This is a discipline within mathematics. I want to say within probability. So that's where this formula stems from. Don't dwell too much on this, especially on an AP exam. What I think you should focus on is on this, the fact that you see the n factorial, the exclamation mark again stands for factorial. N factorial, r factorial, I'm trying to highlight this right here, r factorial, and then n minus r factorial. So I would focus on that because you have a method that does this for you already. And so it's actually this is a very simple implementation. Let me show you. I'm going to come in here and I'm going to try to write this so that it makes good sense. But I'm going to say here, for example, I'm going to say, now again, the precondition is n and r, both n and r are a number between 1 and 12. Inclusive, meaning including 1 and 12. From n choices, prints the result as described in part B, determines the number of ways r items can be selected. Okay. Look, I'm going to do the following. I'm going to say int numerator, so num. It's short for numerator. Num equals. And if I look at the equation, the numerator is n factorial. Okay, so I'm going to say, well, the numerator is going to be factorial. I'm going to execute the factorial method and send it n. Good. And I'm going to say int denom1. This stands for denominator 1. So denom1. And that, I'm looking at this right here because there's 2 parts to this denominator. That's r factorial. Good. Well, I'm going to come in here. I'm going to say I'm going to implement my factorial method. I'm going to place a call to the factorial method, but I'm going to send that r now. And then hopefully you see where this is going. You're going to say then int denom 2 equals, well, now the second part of the denominator would be this, which is n minus r, whatever that is, factorial. And so I'm going to go here, factorial. I'm going to place a call to the factorial method. I'm going to do n minus r. Now I'm starting to think of a case where this is a negative number. I'm saying, what if r is bigger than n? Which, by the way, they ask us to code for that, so we're gonna have to think about that in a minute. But this is basically it, okay? And then we can say, notice how we're not returning anything? Public static void. So this method does not return anything, which means that all we're gonna do in here, we're gonna print something to the screen. We're not returning a value, we're just printing. System.out.print. And what you're printing is actually this right here. So I'm gonna actually copy this. And I'm gonna put my string, my quotes, and then paste. Okay, that works good. Now these, I don't want to hard code. 10, 3, and 5. I don't want to hard code them. So I'm going to say there are, terminate the string, plus 10 is the answer that I'm looking for, plus, and then I'm going to delete this, and I would need a space. Okay, there are, whatever answer is, ways of choosing. I don't want to hard code the 3. 3 is supposed to be the r, so I'm going to terminate my string, plus r, plus, plus, I keep items from, and once again, I don't want to hard code the 5. I'm going to put plus 5 is n, plus choices. Okay, I think I got this. Now, when r is bigger than n, answer should be 0. That corresponds to this test case right here. There are 0 ways of choosing 4 items from 2 choices. In this case, n is 2, r is 4, and r4 is bigger than n2, and so 0 ways. And so I'm going to say here, actually, well, let me write this, something like this. If r is greater than n, I want answer to equal 0. Else, if r is not greater than n, I'm going to say answer equals num divided by denom1 times denom2, which is basically the formula. This is a formula that we're given. Now I'm going to try this. I know that there's something a little fishy here. This right here. Because again, if r is bigger than n, 4, so we have 2 and 4, that means r is bigger than n. This would be 2 minus 4, which is -2, and I would be sending a -2 to this method, and so that's problematic. But let me try this out. I actually don't have to print here. I can just do num combinations. Suppose n is 2, r is 4. So this is the scenario that I would expect it to say 0 choices. This right here. There are 0 ways of choosing 4 items from 2 choices. But that's what it should print. But I'm expecting an error. I don't know, let's try it out. Or maybe not an error, but not necessarily. I never declared answer. Answer is an integer. So right here I'm going to put int answer. I'm not going to initialize it to anything. I'm just going to put an answer. Oh, it works. There are 0 ways of choosing 4 items from... Oh, it works because this is working right here. So, okay, well, let's try 5 and 3, which is the one I have on my answer to the student's question. It's also the one that happens to be... So I'm expecting 10 here. Good, there are 10 ways of choosing 3 items from 5 choices, which is correct. So this is working. I think what happens is that although denom 2, when I send 2 minus 4, which is a -2, I think my answer for denom 2 is not going to be a correct answer, but I don't use it here. I don't, because I'm just saying answer equals 0. So I'm not actually trying to divide this. And I think that's it. Now the question is, should I code this? Should I just put this within the if statement? I think so. I think to just be on the safe side, I can just say, oh, I would have needed the curly braces here. And I could just paste this right here. As a matter of fact, I can do the following. I can declare the variables up here. I believe this is going to work. denom1, denom2. So I'm saying these variables exist. They're all integers. And then I can actually give them a value here. Let's see, let's compile and then run it. And that would be, I believe this would be it. That's it. Now, let me just very quickly here talk about what I did. So I declared, not initialized, but declared 4 variables: answer, num, denom1, denom2. These are all integers. So I'm saying these exist. I'm basically going into my little memory in the computer and I'm reserving some spots. All 4 bytes worth of information. So 32 bits. Because I might put stuff in it. If r is bigger than n, then the only variable that I populate, that I assign a value to, is this variable. Answer equals 0. These are not assigned a value, but that's okay because I'm not going to use them. But if r is not greater than n, then I'm going to say num equals, I assign a value there. This is the numerator, factorial of n. Denom1 is the factorial of r. Denom2 is the factorial of n minus r. And then my answer then is going to be the numerator divided by denom1 times denom2, which is actually this formula right here. It's this exact formula. And then finally I print. There are blank, or there are whatever answer is, ways of choosing whatever r is items from whatever n is choices. And that's it. Notice how this says void. So I'm not returning anything. And I also know that I need a print because it's in the problem statement right here. It says that, where are you? I know I read it. The number of possible, the method, regardless of what you wrote, similar factorials is specified. There's a print here. I know it's print the result right here. So the method is supposed to print the result. Not return anything, but print. And so I know I need to put a print statement, which is also a question on a student's question. Okay, that does it for this video. The one last thing here to note is that this would not be part of your answer to the free response question. This is just purely for our purposes when we're testing our methods to make sure that they're working as they should. So no need for that. The only two methods that you're responsible for are the factorial method and the num combinations method. Okay,